Today we'd like to go deeper. Because it really does seem like there should be aliens. The Kepler Space Observatory has told us there are a couple of 100 billion nice, watery planets in the Milky Way. And probably billions of them are Earth-sized planets. Around sun-like stars. Many of them have been around long enough to produce a civilization that could have easily colonized the entire galaxy by now. So why is the Milky Way so un-Star Warsy? This genuine oddity is referred to as the Fermi paradox and the resolution. For it has to be that there's some sort of great filter that either makes intelligent life extremely rare in the first place or that wipes out, essentially, all advanced civilizations before they get to the galactic empire stage, whether by a nuclear war, environmental catastrophe, accidentally making a black hole that swallows the planet, etc. Personally, I'm not buying it. I just don't think that there's an inevitable great filter still ahead of us. As we saw in a previous episode, we're not so far from building starships ourselves. Surely some civilizations must make it through these growing pains and manage to reach the stars. So where are they? Well, there's another deeply sad and deeply inspiring possibility. Humanity may be one of the very first interstellar species in the history of the galaxy. But before we get all emo, let's science this right. We know of exactly one instance of intelligent life happening, the case of Earth. And as if it wasn't hard enough to do statistics with a sample size of 1, we also have to deal with a massive selection bias. Of course we're going to observe at least one instance of intelligent life happening. Because we are that one instance. In a way, it doesn't matter how improbable sentience is. As long as it happens once, it will be there to observe itself. Here we're touching on the anthropic principle, which states that an observer will always observe a universe that can make observers or a planet that can. We'll talk about the cosmic implications of this more in another episode, but for now we need to acknowledge that this selection bias allows that life could be extremely rare, or even unique. Given that, can we even begin to assess the likelihood of life out there? Yeah, we can science anything. So let's dig into whether we should really expect to see a Solarian empire. Let's take the knowns. Now, Earth certainly required a number of very special conditions to build life, and it's hard to know how essential each of these was or how frequently these conditions are met through the galaxy. I'm going to avoid details of the biology here because we can say a lot just based on how much time it took to get through each step on the path to building technological life. We can crudely summarize the big leaps that lead up to intelligent life as 1, assembly of self-replicating RNA. From organic molecules, 2, RNA-based protocells, 3, DNA and the first actual cell. This is the moment of abiogenesis, life from not life. 4. Increasingly complex single cells. 5. The first multicellular organisms, so plants, animals, etc. And 6. The first intelligent life form capable of counting to 6 on YouTube. Now the crazy thing, the thing that I find the least intuitive, is that the first 3 steps in that chain, combined, the appearance of true cellular life, happened faster than any of those later steps. So fast, in fact, that it seems hard to believe. And in fact so fast that our galaxy probably should be brimming with at least simple life. Let me explain. See, around 4 billion years ago, pretty much just after the Earth had first cooled down from being a giant, hellish magma bowl, we think that it totally got pounded by a meteor storm that lasted a couple of 100 million years. This is the late, heavy bombardment, and it probably obliterated the surface. We think we know this because we flew to the moon and found evidence of it. Up until recently, the earliest known evidence of life dated to roughly 3.5 billion years ago, fossilized blue-green algae beds, stromatolites, found in Western Australia. The place was covered in this greenish-purple slime that reeked of rotten eggs. Yeah, the beach was horrible back then. Basically, Earth was once a giant slime ball planet. And it looks like Earth went from magma ball to slime ball in less than 300 million years. What? That seems crazy fast. But it also suggests that this first step, the genesis of life, is not the great filter. But wait, the abiogenesis thing gets even weirder. See, nature has provided us with a perfect time capsule for studying the very early Earth, zircons, super hard silicate crystals whose formation can be dated precisely by the ratio of decaying uranium versus lead decay product locked inside. And get this, just recently a zircon was found containing the possible signature of life and dated at 4.1 billion years ago, from before the late heavy bombardment. That little crystal contains what looks like biogenic carbon. That's a fancy way of saying there's too little carbon-13 compared to carbon-12. See, photosynthetic. Find C12 a bit yummier, and so it absorbs more of that than the heavier C13. Pretty much all carbon enters the biosphere from the photosynthesizing bottom of the food chain. Any carbon that's been through living systems will have the same C13 light isotopic ratio that we see in this zircon. Now there are other non-biogenic explanations, but this is extremely suggestive that life was abundant on Earth remarkably soon after it first coalesced from stardust, and that life either survived the late heavy bombardment or formed again after that. Or the late heavy bombardment never happened. That's actually a possibility too. But either way, it looks like Earth became a slime ball teeming with life in a crazy short amount of time. How on earth did this happen? Two options. 1. Given the right conditions, the genesis of life happens like that, and 2. It didn't happen on Earth. Life was seeded from space, an idea called panspermia. Look, there's no question that lots of rock gets ejected into space after meteor impacts and can move between planets. We found plenty of meteorites originally from Mars. A lot of the ejecta from Earth is going to be swarming in bugs. Could similar bacterial astronauts have once survived an interstellar journey to Earth? Some bacteria are certainly hardy enough to survive launch and landing. This has been tested. If these bacteria were frozen solid, they could plausibly survive a very, very long journey, and you only need 1 out of billions to make it. Maybe the solar wind pushes infested material into interstellar space so that tens of thousands, even millions, of years later a single bug winds up on a brand new planet. And boom, instant slime ball. Questionable, but it would mean that life only needs to evolve once from scratch in any given galaxy. Now this should be very testable. Earth was infested fast, so that means this stuff should be out there. Mars must have been hit when it had water. Did it go slimeball? There should be something like stromatolite fossils on its ancient surface. We haven't seen them yet, but they'd be hard to spot. These cosmic cooties should be findable in space too. So either fast abiogenesis or panspermia, one of them must be true. However, both suggest that the galaxy should be teeming with slimeball planets filled with life. Now that's exciting. We don't have a telescope to find them yet, but we could soon. These planets will have atmospheres driven by biotic processes. If we could analyze light passing through these atmospheres, we would see signatures of oxygen, ozone, methane, nitrous oxide at concentrations impossible without a biosphere. Properly fund NASA and its terrestrial planet finder, and we could find extraterrestrial life within 20 years. So it's entirely possible that we'll soon discover that the galaxy is filled with life. But this just makes it weirder that the Milky Way isn't swarming with ancient alien civilizations. There is a filter, but it's not the genesis of life. The clue might be that the Earth stayed a slimeball for nearly 3 billion years. The first multicellular organism turned up only 600 to 800 million years ago. And life as we know it quickly exploded after that. Was this a random lucky event that we just had to wait for? No, multicellular life evolved independently dozens of times. It just took a really long time for those single cells to become complex enough to form large collaborative structures capable of collective reproduction, i.e. plants, animals, a species capable of making the Kerbal Space Program. And speaking of space programs, technological life took a little while Longer, but not really so long on the overall scale. Once we had complex life. After the Cambrian explosion, it was only around 500 million years to go from jellyfish to moon landing. Of course, maybe the emergence of intelligence is a random and unlikely event, and this one is the hardest to assess. However, it's worth noting that we do have other species on Earth that seem to be moving down the same big brain path independently of humans. So what is the great filter? Maybe it's just time. If life is common, then of the billions of Earth-like planets in the galaxy, only a tiny fraction needed to have a small head start on us in order to have produced the Federation of Planets and Stargates and stuff by now. So what if humanity started early? Of all of the sun-like stars and Earth-like planets that will ever form over the full past and future history of star formation in our universe, Earth is early. It's part of the first 8%, according to recent Hubble Space Telescope-based calculations. We have emerged in the epoch of life in a universe abundant in the rich resources of past supernova explosions, but after the violence of the starburst and quasar epochs. It strains believability to imagine that life didn't or won't happen elsewhere, but it is possible that we are a very early outlier and that any other civilizations are so distant as to not yet be apparent. Is humanity a first-generation intelligence, one of the species that will watch and maybe guide as other intelligent life emerges throughout the galaxy? Well, there's something to work towards on the next episode of Spacetime. Last week we talked about Miguel Alcubierre's warp drive. You guys had a lot to say. Let's do it. A lot if you noticed. My mistake in saying that Miguel Alcubierre is Spanish, rather than Mexican. That was my mistake. We cram a lot of details into each episode of Spacetime, and sometimes things like this do slip through, so thank you for catching it. Miguel Alcubierre was, in fact, born in Mexico and, in fact, educated up to master's level there. Eric Vilas wonders what it would look like seeing an Alcubierre warp bubble race by from the outside. This is tricky. The bubble would definitely leave some sort of light signature because light inside the bubble can traverse the walls in any direction besides forwards, and our negative mass matter may also end up on the outside. Because the bubble is superluminal, any light that we see would trail the bubble just like the sound of a supersonic jet. Ahead of the bubble, you'd see nothing unless it stopped, in which case all the photons and particles that are captured on its journey would blast you into oblivion. Now, a few of you took issue with my statement that it's never aliens. And fair enough, it's never aliens until it's aliens. The point of this philosophy is that the alien hypothesis is a bad place to start, because you can explain almost any weird natural phenomenon as having been produced by a super-intelligent, extremely high-tech civilization with inscrutable motives. Really anything. It's a weak hypothesis. Until you've generally ruled out everything else or you actually see the mothership and take an unsuspiciously blurry photo of it. So Nate asks if we can please do another challenge episode. Absolutely, we'll do one soon.